Accessing the internal registers of cortex-m3, whether in read or write, will differ from one set of registers to another. To access special registers like xpsr, pre-match control, and bus prio registers, we need to use two sets of instructions provided by the cortex-m3 for such use case: the MSR and MRS. MSR instruction used actually to write to the special registers, and MRS used to read out those special registers. Here we have an example of C-based function to read out the value out of the control register. This function is defined as a static inline, and this to prevent the compiler at assembly level from inserting some crazy assembly routine that may interfere with the returned value out of the control register. However, this attribute inline will not prevent the compiler from inserting what is called the prelog and epilogue basically routine in the beginning and the end of the function. Prolog routine basically means is the assembly routine used to create the stack frame of the function. And the stack frame is just memory space within the stack area used to store the input arguments and the local variables of a function. The epilogue is really the opposite, so it is the assembly routine at the end of a function and used to restore back the stack frame of the calling parent function. So this routine will not be wiped when having this static inline attribute. However, the assembly routine in the middle of a function that the compiler may insert will be wiped, and this will ensure that read will have only this line of assembly code to read the control register. And this of course will preserve the value that we have read out of the control into the result local variable, and this is what will be returned out of the function. The good thing that such APIs to read and write from and to the special register are already included as part of the toolchains headers. Also armed within their CMSS headers, they provide just kind of API abstraction to read and write those special registers. So most likely you will not need actually to write your own routine to deal with those special registers. On the other hand, the general purpose register, we need a different way to read and set those registers. So using those instructions, the MSR and MRS with those general purpose registers is not supported and will create a compilation error. What we do actually, we do kind of hacky ways to read and write those general purpose registers. In this case, we are trying to read the value out of the R3 general purpose register. To do so, the function that will read out this register need to be declared and defined as naked. Attribute naked will make sure first that the compiler will not insert a crazy assembly routine in the middle of a function that may interfere with the lines of assembly codes that we have added within the function. Plus, it will eliminate and wipe the prolog and epilogue routine in the beginning and in the end of the function. This means really what we will get at assembly level is really the assembly line that we have written in the body of the function. There's going to be no extra routine in the beginning, no extra routine in the end, and no extra routine in the middle. And this of course will give us 100% accuracy on what we will get out of the R3 register. However, the drawback of using such attribute is that the full basically routines that will create the stack frame, also restore the stack frame of the calling parent function, and so on, need to be written by us. So we need to make sure that this is written properly and we don't do a mistake there. Then here we are using only simple move instruction to read out the value of R3 and move it to R0. Why we are using the R0 register? We need to go back actually to the calling convention slide, where we say there that the R0 is used also as a container for the return result of a function. So this is part of the ARM calling convention. And we are using basically this fact to get the value out of the R3 and we save it into R0, and then this will be actually the return value of our function. And once we read the value out of the get R3 function, what we will get here will be actually within this variable R3 will be the value of R3 register, because this is the return result of the get R3 function. So such routines in general is not part of the toolchain headers or the CMSS headers, so most likely you will need to write down those routines by yourself.